Looks good to me. We'll get you started in just a couple minutes.
Okay.
Make sure, don't want anyone to miss you. Still have lots of folks streaming in, so I want to make sure we get them in here before we get you started. Um, but good morning, everyone. Welcome to day 2 of the LD4 conference. I'm so happy to see you here, and I'm very excited for this talk from Doug, a FOLIO Quick Bite, the new linked data editor application in FOLIO. Doug joined EBSCO in 2023 to head up a project for adding support for linked data cataloging in FOLIO, and he's previously with OCLC, holding positions in product management and business development. He's based out of Columbus, Ohio. Doug, I'll give the floor to you.
Thank you, Sasha. It's great to kick off day 2 of the conference. I'm responsible for the rollout of oh, okay, I'll keep on going. I'm responsible for the rollout of the new linked data editor, and what I'm going to do this morning is give you a sneak peek about functionality that's coming to Folio. So the Folio linked data editor will allow staff to create, edit, and manage collections as linked data, and it will be integrated into the library's Folio operations. And because this is a lightning talk, I'm going to go straight into a live demo of the application and then call out key takeaways for this audience. The first of which is that the Folio linked data editor the beta is accessible to anyone from the Folio Sunflower Bugfest environment. We spin up Bugfest environments so that the Folio community can test new features and new applications to harden the code prior to a major release. Major releases are named after flowers, and the most recent is Sunflower from May of 2025. So I'm going to just copy and paste the URL. Sorry, one sec. Here. And the credentials are simply Folio to get in. And now we're in the Sunflower Bugfest You don't need to know anything about Folio in order to access or use the linked data editor. All you need to do is to go to the upper right, there's a drop down of applications in Folio. They're listed alphabetically, and just highlight linked data. And you'll notice that linked data editor is appended with beta. The reason for that is that we have some back-end work that we need to complete in order to properly support cataloging workflows. But as far as the look and feel of the application itself, we think we're in pretty good shape, which comes to our next takeaway, intuitive interface. When we approach this project, we're thinking about libraries who want to adopt linked data. Obviously, that's a formidable challenge for them. And so we invested in UX to figure out ways where we could make linked data principles self-evident to cataloging staff. And two of those concepts are around work and instance. And in a nutshell, the work is bib data about the story or the idea, and the instance is bib data about the publication itself. So I'm going to go back to the linked data environment, and I'm going to illustrate that in two ways. First, I'm going to do a title keyword search to illustrate our search result sets. And I'm going to actually scroll down here to make a point. We wanted to represent the hierarchical relationship between work and instance. And so the work is featured up front. The title, the creator, language, classification, those are bib elements that roll up to the work. And then we list as a table format all the instances that are associated with the work. In this case, these are different editions of the same work. And when we showed this prototype to our pilot libraries, one of the catalogers who didn't prior have experience with linked data commented that, oh, this is a massage for my brain. She was thankful to see and understand what we were trying to do here between, or showing the relationship between work and instance. I'm going to now move into edit mode, but I want to do another search on vocabulary so I can start with a simple search result, a work with a single instance. This is a Middle English Vocabulary by Tolkien. To get into edit mode, you can either select edit work or edit instance from the search result set. We're going to go into edit work. And what we've done is we've divided the screen between work and instance. Work is on the right side, and the metadata elements that roll up to work are in edit mode, whereas on the right side instance, those elements are displayed as read-only. And we provide the ability for the cataloger to toggle in between work and instance from this action dropdown. So if we select edit, now the instance elements are now displayed as editable, and on the work side, those elements are displayed as read-only. And the layout here, I think the intent was to address two things. One is we wanted to simplify navigation for catalogers, especially those who may not be familiar with the work and instance. By grouping it this way, we were trying to simplify how the catalogers could navigate within a bibliographic resource. Second is that this layout allowed us to get quite a bit of the bibliographic resource above the fold, if you will. So we're always looking for ways to make this display even more compacted so that we can limit the amount of scrolling that catalogers would have to do, which is disruptive. So we feel like we've made some progress on both those counts. Okay, so now we get to takeaway 3, integrated with Folio. So let me go back to the Sunflower environment. I'm going to exit from linked data, and I'm going to pull up the inventory app. Inventory is simply available by going to that apps drop-down list. The inventory application Folio is kind of its brains and its heart. It keeps track of everything that's in the library's collection as it's registered in inventory. The simplest way to see that is under the search limiters, just open up source, and you can see in this case that there are over 8 million records in this environment with source mark and almost 500 for linked data in addition to those other formats. So the point here is that within FOLIO, catalogers or the library staff can have mark-based cataloging side by side with linked data-based cataloging, and you can search all of it from one interface. So let's do that. Let's search for that last title that we saw in the linked data editor, and we're going to limit this to, so we have over 3,000, let's limit it to linked data. And now this is the same title that we saw in the application. Over on the right side, what you're seeing is the inventory instance record for this title. Inventory spins up kind of a generic or vanilla record for everything that's registered in inventory. So it doesn't matter what the source is for linked data or mark, what have you. Every of those records has a record like this. And this is where catalogers could do more work. So for example, if you wanted to edit this work, you could launch the linked data editor from here, and that would open up the linked data application again to that same record. Another thing that catalogers would do here is manage items and holdings, which they could access this way. The importance of that is that it doesn't matter what the underlying source is. Here it's linked data, it could be mark. It's the same workflow. So you do your descriptive cataloging in the linked data editor, then you come here to finish the items and holdings. It doesn't matter, it's the same workflow. One more thing that you can do is export instance. In this case, if you were to select that, it doesn't actually export the record itself. What it's doing is returning an identifier for that record. And what you would do with that identifier is you could go over to data export and retrieve it. I'm not going to go through the steps of doing it. I just want to show that midway through this log, we have Middle English vocabulary. I did this prior to the presentation. That's a mark record, and it's available, shown right here. So why do we do that? Well, it's clear that libraries will be mark-based shops for the foreseeable future, and typically what that includes is downstream applications that require mark. So the story here is that you can run your cataloging in the linked data editor, and you can provision that cataloging as mark records to feed those applications and support existing operations. Okay, so now the production release, takeaway 4.
Just a note, Doug, we're at 1 minute left.
Okay, so this is due in November, December of this year as part of Trillium, and that will include the ability to do descriptive cataloging of monographs, rare books, and serials. You'll be able to import or export records as MARC and as RDF. So if you have a BibFrame file, you can pull it into the application and you can provision it as BibFrame. The last thing is we'll be renaming this. Linked Data Editor was always provisional. We understand that there are other linked data editors out there, so we're going to give it a name that reflects its design and purpose. This is our linked data product team. Gloria Gonzalez oversees linked data initiatives at EBSCO. Alvaro is the product manager, and I'm the launch manager. We invite you to check out the linked data editor in Sunflower Bug Fest. Feel free to ask us questions, or we welcome the feedback. So I'm at time. I hope you enjoyed this and hope you enjoy the rest of the conference.
Thank you so much, Doug. We do have 2 questions for you in the chat if you have some time to address them now. But I want to go ahead and get started with our next presentation. Andrea, if you want to pull up your slides.
Yep. Share my screen, right?
Yes, please.
Okay. Let me. Yeah. Can you see my screen?
Yes, I can see it right now. I can see the full thing, not presentation mode.
Okay. Can I start or?
Yeah, let me go ahead. I'll do
once.
your introduction for you.
Okay.
Here we're going to see Andrea is doing about leveraging linked data fragments for enhanced data publication. Andrea is a software engineer with over 20 years of experience in various software engineering areas, from telecommuting to banking. He's an open source software passionate and Apache committer. His adventure with the search domain began in 2010 when he met Apache Solr and later Elasticsearch. Since then, he's been the search engineer in many projects in different fields: bibliographic, e-government, e-commerce, geospatial. In 2015, he wrote Apache Solr Essentials, published by Packet Publishing. In 2018, he founded his company, Spazio Codice. Since 2020, he is the tech lead of the Share VDE project, a library-driven initiative that brings together the bibliographic catalogs and authority files of a community of libraries in a shared discovery environment based on linked data. Andrea, please take it away.
Thank you very much. So, yeah, real-time RDFization. I don't know if the word is correct, but it gives you the idea. So we are going to see how in the ShareVD project we leveraged the linked data fragments approach for publishing RDF data. Sasha already gave a great introduction, so I'm going to skip this. So first of all, what is ShareVD? Is a library-driven initiative that brings together in a common environment, sharing the environment, the catalogs, bibliographic catalogs and authority files of a consistent number of leading academic and national libraries from North America and Europe. So I would say that ShareVD is something like depicted in the image, something that sits in the middle between the different parties. So behind the scenes, we have a knowledge base, what we call a knowledge base, which is composed by a set of different storages where we store data. And let's see how it is creating during the ingestion process. We have different participants that contribute with their data. Data can be MARC or RDF data, and we have inbound API for providing streams of records or an integration based on file, on FTP or file exchange. So this data is pre-processed in order to enrich, duplicate, integrate the entities that are in the original data, and the result is what we call Sapientia, the ShareVD knowledge base. The domain model, the shape of the entities that are in the knowledge base is very similar, very close to the B-frame domain model. Here, the core hierarchy are depicted on the left, and you can see that it's very similar to the B-frame hierarchy. The main difference is that we split the responsibilities that are in the B-frame work across two different entities, work and opus. But I would say that apart this difference, the remaining part of the domain model is very, very close to the B-frame model. This is the graphical representation, the diagram that illustrates the contributions. So if you, as I imagine, if you are familiar with the B-frame, you will see a lot of similarities. So the contribution, the role, the agent can be one of the 4 subclasses below. And we have other things, other entities like subjects, like concepts, like minor, entities that don't belong to the core hierarchy, like topic, date, place, event, and so on. And of course, they are connected with the entities belonging to the core hierarchies. Um, mm, what about the single entity? I mean, the agent, the opus, the work that we've seen in the previous slides. We call those entities prism. I mean, the fundamental entity of the Sapienza knowledge base is called prism. Why? Let's assume that a library uses FOLIO in this example to manage its data that is contributed to shared VDE. So in this case, a bibliographic record, let's suppose. That bibliographic record is pre-processed, and every entity that is within that record is detected and a bibliographic record is the instance, so the orange triangle with the corresponding attributes. But apart from the instance, maybe I have some connection issues. Let me know if apart from the main entity, the instance, the bibliographic record contains also other entities like agents, like publishers, like works, and so on, the small triangles. And we store the fact that those entities have been contributed by a given library. So in this example, I remember it was Stanford, maybe. Okay. Those triangles are contributed by Stanford. What happens if another library, another participant contributes with a bibliographic record that contains the same entities or the same bibliographic record, the same manifestation, I mean, uh, mm, it will happen the same process, and that library will create other triangles, but belonging to the same entities. The pre-processing phase is able to detect, to deduplicate those entities and to group the triangles that belong to the same entity. So, and that's why we call the grouped entity a prism. Share VDE, the system, gives a URI to each prism, and each prism always retain the different phases and the corresponding provenance of those phases. So here comes the linked data fragments approach. So this is the big picture of ShareVD, how it works. So on the left side, we have the participants, the libraries that contribute with their data and create the ShareVD knowledge base. Then the data is the ShareVD knowledge base behind the scenes is composed by different kind of storage, a relational database, an inverted index based search engine for providing search services, and an RDF store that contains RDF data. The first two are used in a GraphQL, are used, sorry, to provide a GraphQL and REST API layer for clients for the UI. And the third one provides the SparkQL interface over HTTP. The right part is out of scope for this presentation, but it is related to the edit API. I mean, through a set of edit API and an edit UI called JCricket, we are able to edit what the ingestion process created in terms of entities within the, the knowledge base. As you can see, there is a lot of redundancy because the same data is in different format for different purposes in 3 different places. 2 of them are crucial. The RDBMS, because it's the primary storage, and the search engine, because we use a lot of search features that cannot be provided using another form of database, NoSQL, RDF store, or even RDBMS. We need a search engine. Think pasting, auto suggestions, aggregations, and things that you can see in any search engine. So our presentation is about the third part, which is related to the RDF store. We tried to avoid the RDF store at all because scalable solutions in terms of RDF store are very expensive. The open source scenario is not very good for these kind of products. And if you want to have something that scale, that with a high scalability, I mean, you have to use commercial products, which sometimes are very, very expensive in because we are using a huge amount of data. So let's analyze a simple SparkQL query. So we have a first part which is used just to simplify the query below. So we have a selection where we define the variables that we want, that represents the data that we want to capture, and a set of query statements in terms of triples that represents the selection criteria. This part can be theoretically executed in parallel and then intersected. So each of them can provide a partial view of the overall results before merging everything. That partial view is called a fragment, a linked data fragment. Or better in this case, when they are expressed in a SparkQL query, they are usually referred as triple patterns, because the triple can be composed by 3 literals or 1, 2, or even 3 variables. So it more like a pattern. And so what are the participants of linked data fragments interaction? The clients, of course. Clients are those applications, UIs, and so on that are interested in request SparkQL data, better RDF data through SparkQL. And there is a SparkQL interface and a service that, of course, provides that interface. The difference between a traditional RDF store and the linked data fragment approach is here. The SparkQL HTTP interface and the storage is provided in the first block in case of the RDF store. It's more, how to say, monolithic from this perspective. In a linked data fragments architecture, the the role of this component is to provide the HTTP interface, the SparkQL over HTTP, destructure the several triple patterns in the selection criteria it finds in the query, and then delegate the each pattern to a simple service called Linked Data Fragment Resolver, which is in charge of exposing a REST endpoint, a simple REST endpoint that is able to resolve a single triple pattern. I mean, a query composed by three variables, subject, predicate, and object, where one of them, two of them, or even three can be variables. And the linked data fragment resolver doesn't need to fetch the data from an RDF store. It can fetch the required data to resolve the triple pattern using any storage. In this case, we are using a mix between the relational database and the search engine. But okay, it's up to the specific context of scenario and better architecture, because another architecture could have a NoSQL database behind. And the cool thing is that everything is executed in real time. So there's no need to store the RDF natively using an RDF store, but data is organized according to the project criteria in the relational database and in the inverted index. And it is transformed in it is translated in RDF according to a given ontology or set of ontologies on the fly. And that opens a lot of possibilities other than removing completely the RDF store from the architecture diagram. Yeah, this is a big picture saying that this is the same picture, but it focuses on the fact that the triple pattern server or the linked data fragment resolvers here are very, very simple servers that can be stateless servers, absolutely stateless, that can be scaled very easily. So you can have a huge number of instances of those servers that are playing behind the scenes. And this is specific to our case study. Everything was working, but with this high scalability, with the high scalability provided by those simple linked data fragment resolver, we met a bottleneck in the relational database. The relational database, in this case, Postgres, are not so good for horizontal scaling when you are talking about a huge amount of data. So we are moving, because the project is in progress, we are moving to a NoSQL storage that offers, unlimited scalability, horizontal scalability. Because otherwise, the architecture of the relational database became too huge and with a lot of problems in terms of maintainability, basically. So this is the same picture depicting the overall architecture, and using the linked data fragments, we just remove the third part. So what are the two examples of the benefits of working in terms better translating and providing publishing RDF in real time? So one thing is the client using regular HTTP procedures like, I don't know, the header negotiation used for the content type negotiation, for example, can request a specific subset of data coming only from provenance A, B, and C. So I want, in this example, the client wants to get back the agent 201. The agent 201, as we know in the knowledge base, is a prism composed by the contribution of all libraries. The client here, through this custom header, but is just an example, wants to get back the agent 201, but it wants only the phases contributed by the University of Pennsylvania, Alberta, and Chicago. And this is very easy in this context, because we know that we have a prism. Once detected the proper prism associated with that URI, we just need to select the phases we are interested in. And the RDF that is returned back would contain only those contributions. Using the same logic, sorry, this animation, yeah. Using the same approach, we could have the clients use another header for negotiating the shape, or better, the ontology set used for translating the data in RDF. So again, we do not store RDF using this approach. So that means that we don't have RDF in the system, in the storage, and we are able to create that on the fly. That means that on this request, we can answer for this agent using a mix of the Wikidata and yes, and BibFrame ontology, because the client requested that specific mapping. On another request for the same agent, we could use another kind of mix, schema.org and Dublin Core. This is possible because, again, we produce this RDF on the fly. And these are just two examples, and they are not alternative. So one client could request the same agent, the agent 201, using a given mapping code, which represents a set of ontologies that are used to produce the RDF. And using the header of the previous example, it can select only 4 provenances among the whole contribution set. Again, this is very, very interesting. This is very interesting, and we started thinking to this approach mainly for getting rid of the RDF store for cost reason, basically. But once we started using the linked data fragment, we found that very, very interesting in terms of potential things that we can introduce in real time, at query time. Okay. And I think that's all. Am I in time?
Yeah, that's wonderful. Thank you so much for sharing.
Oh,
That's incredible architecture. We have 5 minutes left in your session, and we did have one question in the chat if you have time.
yeah.
There's one saying, are you saying individual components of the triple can be more complicated than a single element? There was a conversation yesterday about including quads or quints instead of triples. Is this related?
Uh, Individual components, you mean just the component, the API component on the right? Because these individual components are not more complicated. I would say that are simpler than a monolithic server that must satisfy the whole execution path of a SparkQL query. In our example, here we um, we would have, let's assume, 1, 2, 3, 4, 5 linked data resolver that are in charge of resolving only one triple pattern instead of like what happened in a monolithic RDF store, where the server needs to execute the whole query. There is a price to pay for it's not everything free, let's say, because in a monolithic storage, the server is in charge to execute the whole SparkQL query, which is more expensive, but it gives space to a huge number of optimizations because the server controls everything in the same place. Here, every triple pattern is delegated to a remote server. So the role of the SparkQL server here, the role of the SparkQL server here is just to deconstruct the different, separate the different triple patterns, delegate their execution to a simple component, get back the result from all the resolvers and merge the final result before returning everything to the client. There is a bit of space for optimizations, but of course, as you can imagine, the latency and the space for optimization is the latency could be a problem, and the space of for the optimizations is smaller than a traditional monolithic RDF store. I'm not sure if
I think that was helpful. And I know Jim was also helping to kind of resolve that
okay.
question in the chat. But Amanda said this, it was beautiful explanation. So we appreciate this is such a creative solution. We're at time now. If you still have a chance, I didn't see any additional questions in the chat, though some may come through. But we appreciate it so much. Thank you for sharing your work with us.
You're welcome.
All right. We have coming up next, Hugh, if you want to share your slides.
Well, I'm going to play a video. Hello, everyone. And I'm going to share my browser screen live, which could end in disaster, but we'll try.
While you cue that up, I can start with your introduction. So
Cool.
we're looking at exploring OCLC's entity platform, a linked data tool for visualizing provenance. Hugh's the technical services librarian at Mannix Library and University of Divinity. specialist in rare book cataloging with backgrounds in computer science, art history, cultural material conservation, currently exploring methods for enhancing Mannix Library's special collections using various linked data options, including OCLC's Meridian service. Amy isn't able to be here today, but we are going to be seeing something from her, I believe. Dr. Amy Isham majored in English at the University of Tasmania with a special interest in British literature and philosophy. Amy has a Master of Applied Science from Charles Stewart and a PhD in Regional Development from Federation University. Amy is the library manager at Mannix Library, writes academically in religious studies and social sciences, and is an associate at the Center for Public Christianity. I'll hand it over to you now.
Okie dokie. Hopefully everyone can see my screen.
Looks good.
Okay, just a short intro. We've been working with OCLC's Meridian service since late last year, early this year. And it's been a journey. We initially just got it as a bit of professional development. What can we do with linked data? It's the future. And it kind of exploded from there because we got really interested in it and ran some projects. And I made a way of visualizing the data that we got out of Meridian that connected everything contextually to our special collections. So our little presentation today is going to really take a theme, the theme of Gothic literature, and try and explore its context within our collection and how we view the entities from Meridian. So I'll play Amy's part of the presentation, and she can take you through an introduction to that, and I'll go from there and explain further. Okay.
Hi, I'm Amy Isham. Welcome to Exploring OCLC's Entities platform. I'm Amy, as I said, and I'll be working with Mr. Hugh Sandover later, who will give us a bigger picture on the technical side of this, but I'm just here to give you the fun literary side of things. So we've been working with OCLC's Meridian since November last year. We've tried a few different projects, but one of the things we found was that it was difficult to get enough data, and we ended up rekeying in. So when we picked this project, we decided to work with Gothic literature, and I'll tell you why in a minute. But we're starting with Strawberry Hill. Strawberry Hill was important for this project. It was kind of the central point, and you'll see why later. Because Meridian is kind of a thing that works with making connections between other works, other entities, and entities could include people or organizations or places. We found that we struggled to make the connections sometimes. I'd create a project and go, oh, I'm going to connect this to this, and it was hard to find enough data. So in this case, we started with Strawberry Hill House, which you can see, I'll just move me, in that top right, that's Strawberry Hill House. That was a temple of kitschy Gothic that Horace Walpole created as just a celebration of the Gothic aesthetic that he was really, really into. And it inspired him writing the first Gothic novel, which is The Castle of Otranto. And later on, it had a subtitle, A Gothic Story. And you can see in the top left there a beautiful cover from our own collection, our own rare books collection of The Grave, which was written by Robert Blair in 1743. And I think this was the edition that we have is a bit later because it has some beautiful engravings. So we digitized those for you. In the middle, you can see the title page of Castle of Otranto. And in the bottom left, you can see the picture gallery in the Strawberry Hill House, which is actually really beautiful. It's red and gold and it's dramatic. And all the rooms are much, much smaller than you would expect. So the reason why we picked Gothic literature, though, is not just because it's cool and we like it, but because the connection with our rare books. And you can see this book here was one that was actually, you could see Horace Walpole's name on the subscription page. He was a patron of this book, which is called Antiquities of Great Britain. And this beautiful book really celebrated an aesthetic that was popular at the time called the sublime, which was what you would describe as something that gave you a sense of awe and terror in the unspoiled or ruins, the ruined landscapes. And there was a lot of ecstatic poetry that was what they described as elegiac or elegies about death, or the grave is kind of one of the first known as one of the first Gothic poems. So we're coming into a time where history and science and philosophy and aesthetics and art are really changing, and they're very fascinating to us. But we also found that the great thing about Gothic literature is that there are a lot of works, like so many works, and the entities already exist. Horace Walpole's already there. He's already there alongside all the other people that were also writing Gothic literature. We can see his influences. And the work that we mainly did was trying to connect one work to another work, or one entity to a work, or recognize that someone was inspired by somebody else, because we were trying to map. Like, I'm an anthropologist or ethnographer. I'm very fascinated with how things connect and why they connect. And as I work in an academic and theological library, I thought it might help to map and visualize and help with some of our lecturers' projects, but they just weren't old enough, whereas this one was. So let's get into works. So you'll find when you're working in Meridian, there's a lot of works. You can find the Castle of Otranto, you can find all the other editions. It's everything is there. And that was so much better for us, because we would spend a lot of time trying to connect an author to a work, or go, oh, this work's not even able to be harvested because it's not a book, it's an article. And a lot of our lecturers wrote articles or chapters, not books, or they're a lot slower. So the outputs are just not as much there. And so the enhancement of the description and make those relationships was just a lot more enjoyable, a lot easier. And we found, again, some entities would be missing. I tried to map a historic event which wasn't terribly well known, and I should have thought that it's not going to be there. But the great thing about the Gothic literature is you can see who did what, when. There's a timeline, and you might do a bit of tidying, but it's mostly already there. And the great thing about it is, as we were doing this project, Hugh created a visualization app to try to get a sense of how the OCLC ontology actually connected one thing to another. And so he's done some GPS and other works to kind of deal with the spaghetti of all the entities. So this is me just visualizing it through my Adobe Express, but Hugh's done some more mapping of this connection. So if you look at a person like Horace Walpole, who's just, the Gothic nerd of his time, and he built his own house, and he inspired other people to build their own houses, and they were happy when they fell down because they were ruined. Yay, we love ruins. But you see that he inspired not just Clara Reeve, who's probably not super well known, but her book, The Old English Baron, is basically a retelling of Castle of Otranto. He inspired Anne Radcliffe with her Mysteries of Udolpho, and she went on to have quite a successful career as a Gothic novelist. And then obviously Mary Shelley's extremely well known for not just being the daughter of a very well-known feminist activist, but she wrote Frankenstein, which is probably one of the most influential science fiction Gothic novels of all time, and has inspired so many more. And then, of course, we have Jane Austen, who's one of the greatest English novelists ever, I would have to say, and she made a direct reference to Mysteries of Udolpho in Northanger Abbey. So we have these things that make the connection. So what if you were a user and you're trying to find a book in the library and you just want to read Castle of Otranto? Wouldn't it be great if they also said, you might also like Frankenstein, you might also like Mysteries of Udolpho? So it's not that we're able to really make a project that changed the world, but it helped us to just explore the possibilities of linked data. So here's just a little bit more information. I found this really, really fun. it's interesting seeing that one house could inspire a whole genre of literature, and then when you reach peak genre, you get the parodies, which is obviously Jane Austen's parody of Northanger Abbey is really, really funny. It's not serious at all. So I'm going to finish up there, and I'm going to hand over to Hugh, who's going to show you how he used an app to use the JSON format in Meridian's software and take some of the entities and works and relations that we worked on. And he also decided to go off down his own road and make some new discoveries of his own. So I hope you enjoyed a little ride through Gothic literature, and I hope you enjoy the rest of the presentation. Thanks for having us. Bye.
Okay, I'm going to go a little bit off the beaten track here and talk a little bit about paint, because in my other career, I'm a conservator, and I've been doing a project that identifies pigments. And along this journey where I was learning how to do this, we really came across this story of the really early invention of the pigment Prussian blue. And this is a real Gothic story in itself, because a German chemist, or maybe we could call him an alchemist, really inspired this pigment by contaminating some potash, selling it to another guy who mixed it with blood and produced blue. So what he was trying to do here was to create some red dye made from crushed up beetles, and that's the alizarin you see here. But actually what he got was Prussian blue because he bought contaminated potash. And these two guys got together and made the pigment, and it became the very first synthetic pigment. And that's, I think, important because this is the genesis of science fiction, making things out of other body parts. I mean, this pigment that I made here is actually a Frankenstein in itself. It's rabbit glue and blood, essentially, that makes that blue pigment. So what's all of this got to do with linked data? Well, when we started working with Meridian, it was very hard, I think, to visualize how all the relationships between these things work. So I thought, why not make a network graph? And over time, I used Python to create this app. And this is the basically the network graph that Amy was referring to here, of all the Gothic authors of this early period mapped together. Before I talk about anything else, let's trace our Prussian blue. So Dipple, this guy here, he was actually born in a place called Frankenstein Castle. And the story goes that Mary Shelley heard of this particular story, and Dipple was accused of robbing graves and all sorts of things, and this directly inspired Frankenstein. So I thought, okay, how easy is it to trace this around back to her using linked data? And it actually turns out to be a really short route in two directions. So it's very circular. If we start here at Frankenstein's castle, we can go to Dipple. We can go to a guy called Diesbach, who was the guy who had the contaminated potash. We can go through to a guy called Scheele. Scheele is quite interesting because he also created emerald green, or Scheele's green, the problematic arsenic pigment. Let me go through. He inspired a guy called Humphrey Davy, a British chemist, who corresponded with Shelley Percy Shelley. And then we get directly to Mary Shelley. So that's actually quite a quick route. Did you hear that story that way? We can also go in the other direction. So Dippel to Swedenborg to William Blake to the publisher, Joseph Johnson, who published the works of William Godwin, who was Mary Shelley's father. So that's a quick route in two directions. We've got influence from Frankenstein's castle going to Mary Shelley, traced through this visualization, which I thought was really fun and cool. But there's lots of other things we can do with our data here. I've preloaded it, and actually, if you want to have a play with the graph itself, I'll paste it into the chat and you can go and play. It's a static version you can play with. Otherwise, the real app requires a subscription to Meridian. But if you want to have a play with it, I'll place that link in the chat too. Which is here. Okay. So we've got our map, and that's great. But there's more connections we can make. So Amy talked about the things in our special collections, and here we can actually draw in some other linked data through our AAAF manifests from our digitizations. This is pretty cool. And what you really see here is figures dwarfed by the landscape, very Gothic type thing, a ruin. But also what's down here is these Gothic arches. Now that's really interesting because this other book that we've got here also shows that trope. So this is something I spent quite a lot of time working with, restoring. It's a beautiful, beautiful binding from 1858. Well, what we see here is the Gothic arch. So again, we have these two things connected visually, contextually through the data. My favorite thing though is the little flying hourglass bat wings. A little bit crazy, very Gothic. This book is really interesting too because it's a very early synthetic dye that makes that color, a really dark purple. Previous to this, really, purple didn't exist really until the invention of moving. So again, you see like this intersection of the chemistry, science, art is all like fermenting together in this period. Can we visualize dates? Yes. So really what you'd look for here would be clusters of dates, and they don't really with this. It's very diffuse. It's quite spread out. So what else can we do? I've pre-done it here, but I've enabled the community detection using the Louvain algorithm. So we're detecting quite a number of different communities of entities, essentially. We have our group with the authors, so Mary Shelley, William Godwin, Clara Reeve. We have the Walpole group, and you see that Walpole is a very highly connected entity. You have the Byron group here. You have the pigment group here. And you have the publishing and art group here. So Blake, the publisher, Joseph Johnson, Henry Fuseli. And lastly, the little group on their own. So that's Jane Austen and Anne Radcliffe and their works, which are kind of a little bit later and a little bit separate. You could probably think to this group. So that's why they're kind of sitting off and quite separate. So once we have the data, we can calculate some mathematical algorithms that give us some information. So here we can find how these things are connected. So who is the most central figure in the group? And according to the data, yes, it is Horace Walpole, but he's equal with Byron. If we have a look at the visualization again, we can see, yeah, Walpole just has a group. He's an octopus. He's got so many little connections coming out of him. If we look at betweenness, though, so Byron is sort of way down the list when you look at betweenness. Betweenness really identifies nodes that act as bridges or information brokers. So, yes, Walpole's influential because he has so many connections coming out of him. Same with Shelley. But Shelley has quite a different type of betweenness if we look at the graph. So Walpole just has things coming out of him, but Shelley is very bidirectional. So she's influential because she's exchanging data back and forth between different groups of people. So her husband, Byron, and so on, and her own family. So closeness is very interesting. Closeness really looks at nodes that are capable of rapid interaction. So very naturally here we have London. And if we look back in the visualization, yes, everyone's passing through London in this group. There's a huge number of directions coming out of that node. Now the eigenvector, I just like saying eigenvector, but it's quite interesting. It's sort of how cool you are by association. And quite naturally here, Walpole, with all his connections, basically becomes the coolest entity on the graph. And PageRank is very similar. Okay. So what else can we do? We can do some machine learning. And we're using two type of models here. One is better than the other, I would have to say. But Node2Vec does a kind of probabilistic similarity search. So we can pick and choose here who we want to. This is the recommendation engine that Amy was referring to. So if we go and find Jane Austen, what's it recommending here? Northanger Abbey? Yes, probably the prime Gothic novel or the only Gothic novel that Jane Austen wrote. So it's going to recommend it. Mysteries of Udolpho? Yes, Anne Radcliffe, and going down from there. These entities you see here came in actually from RDFS reasoning, which I applied. It's brought in basically a bunch of different entities that weren't part of the original graph. So actually we can look to see what this missing entity is and see if we can find its relevance. So I'm going to go over here to Meridian. Let's find out what this entity is. Thomas Bentley. Very interesting. So again, it's kind of that art connection. It's coming in. And quite often with these semantic models, it gives you these out of the box things that you wouldn't normally think of. And it's really, really fascinating to me how they come in. But usually if you do some research, you can figure out just how semantically they're connected. So there's a lot of rich data with Meridian, and we spent a lot of time enriching it ourselves. So we can also use textual semantics. So that's the text sentences model. I'm hosting this at Hugging Face, which is the machine learning kind of repository. And they're hosting the text sentences model. So that's why it's sitting here. Let's try a semantic search with someone.
And Hugh, just to note, you have 3 minutes left in the session.
Okay, I'm going to wind up in a sec. Let's try Jane Austen. And recommending, yes, Clara Reeve, Mary Shelley, William Blake, interestingly, Percy Shelley. So things, yes, that do appear to be highly semantically related. I mean, it's not going to relate them to the pigment guys, for example, because they're just not semantically related. Since I'm at time, I'll stop here and not ramble on anymore and see if there's any questions.
There is one question and a lot of excitement. Everyone just loved how metal everything was and how cool and pretty. But the question that we had was, are there any recommendations for reading about community detection or learning more about how these centrality measures work?
Yes, so primarily it all comes from network theory, and they're really mathematical models. So community detection is something called Louvain. I can probably dig up some links for everyone and post them somewhere if that's possible.
That'd be great.
Cent
We can forward it over
yeah.
in the Slack for you.
Centrality is another mathematical model. I'm a bit hazy on what's going on there, but there's the different so betweenness, closeness, centrality, eigenvector, and so on are just mathematical models that run different types of formulas on what they want to show you. The interesting one is I think eigenvector is what Google adapted for use with their search engine. And the idea is that the coolness is connected by the number of links that go back to you, which is like what we saw with Walpole and Byron and so on. They're very highly connected by other people, which rises them up. That's how the eigenvector works. But yeah, I will definitely post some info somewhere if you provide me a space.
Definitely. I can get you either, we can post it on the Sched, we can post it in the Slack, we can get folks in the chat, whatever makes the most sense for you.
Okay, cool.
Wonderful. Thank you. So that was incredible. I think seeing those connections, that's exactly why I love linked data. So this was a wonderful presentation. Thank you so much for sharing your work with us.
No worries. Thank you very much, everyone.
All right, we're right on time here. So we have what's coming next is what's new in the Library of Congress Linked Data Service. And you all are welcome to share your slides, and I can get started with your introductions while you're working on that.
Okay. How do I share my slides? Let's see.
If you go down to that little share box, should let you do it. So you can share your screen.
Let's see. Share. Let's see.
Hooray.
Is it everybody
I can see
my
right now
slide?
the full screen. Yes.
Okay. So let me see if I can pull it into the display mode. Ooh, where's my mouse? Sorry.
No problem.
A little bit technologically
Zoom
challenged.
always takes a minute.
Let me see. Okay, let's see. Is it in the
I'm seeing right now the speaker view. So I have the timer in your notes as well.
Oh. How? You cannot see my slides?
I can see the slide, but I can see the notes as well. So I can see the full presenter view right now.
Oh, okay. How do I get rid of the note?
Maybe share the full screen version.
Display setting. Show task. Is this working better?
Yes, that's it.
Okay.
That's what I want to say.
Okay, great.
Oh, so I'll start quickly with your introductions and we can get you going.
Thank you.
So Helen's a linked data technology specialist and librarian in the network development and MARC standards office at the Library of Congress. She supports the development of libraries' linked data service, id.loc.gov, and actively participates in ongoing development of the BibFrame standard to bring bibliographic description and data exchange into the linked data environment. Before joining the Library of Congress, she led the Digital Library Services Group at the U.S. Geological Survey, where she oversaw key initiatives in digitization, metadata infrastructure, and public access to research data and publications. She's passionate about applying emerging technologies to improve knowledge management, promote data interoperability, and support long-term access to cultural and scientific information. We also have joining us Nate. He is a linked data specialist, librarian, and application developer at the Library of Congress, where he's worked for almost 34 years. He has been active in library standards work for the past 25 years, working on the BibFrame, METS, MODS, Premise, and Alta Data standards, and various digital library implementations using those standards. He's worked on the library's linked data site, id.loc.gov, almost from the beginning. Recent work is focused primarily on maintaining the library's BibFrame database for catalogers, responding to cataloger search needs, and recommendations, and recommending updates to BibFrame ontology or ID datasets to facilitate bibliographic description in a linked data world. Thank you both so much for joining us.
Thank you for the introduction. So today's presentation is going to talk about Library of Congress Linked Data Service and what's new and what are the new developments in that service. And so we're going to talk, for people not familiar with id.loc.gov, which is the website for the Linked Data Service. And I'm going to give a brief overview. And then we are going to talk about a few new developments in that service. Okay, so ID was, I think, created around 2009. And the main purpose for that service was to provide access to the library's controlled vocabularies, bib data in the linked data format. And so each resourcing ID has a unique URI. And we also support download of those data sets in various serialization formats, such as RDF XML, JSON, and N-triples. And we also enables linking to some other related concepts in other ontology or non-library Congress vocabularies. And also for the ID, and we have the ID was mainly created for machine-to-machine access to the data sets, but we also have a web portal that you can do a search and browse the data sets. And so one of the new development we have done recently is to create an API portal, because a lot of people access our data through our API, but we get feedbacks about how these APIs can be used. So we created a portal to provide a formal documentation about how to use these APIs. And this service is created using a standards called Open API standards and a Swagger. So these are the links to the new service we created and the standards we used. And this is a screenshot of the new API documentation portal. So from the ID website, if you look at the left navigation menu, there's a new API documentation beta link there. So once you click on that, you get onto the API portal. And we listed all the APIs, API documentations on the left menu too. So if you choose one, you see the documentation for that API. And so there's several sections in each API documentation. At the top, we provide a JSON format documentation that you can download. And maybe you can import into your application to use the API. And also, we also provide some detailed descriptions about this documentation. And sometimes they're not collapsed. So if you click on the arrow on the details, you'll see a description. And if you want to try the API through this portal, and you can click on one of the this path, that's what's called in Swagger API, in that little down arrow. And so you get to the section that you can try out this API. And so that's one of the services we developed. It's in beta. So we like everybody to give us feedback how we're doing on that service. And next, I think my colleague Nate is going to talk about other new developments.
Yeah, can I share?
So I will stop sharing.
Is that sharing the full screen yet?
It's showing the full, I can see the PowerPoint as well as your slides. And now I see presenter view.
Here we go. Is that better?
Perfect.
Yes.
Okay. All right. So I'm going to talk about the changes that we've made in the actual data. There's control vocabulary changes and then some stuff behind the scenes and some changes to some of our APIs and services. The biggest one that we changed is by adding 639-3 language codes. There's about 8,000 of them. And so that's pretty cool. And if you go to the homepage at id.look.gov, you'll see all of our languages listed there. And actually, all of those images in my part of the slide are clickable. So if you're following on the presentation that we uploaded, you can just go to those sites if you want. So we have a lot of the ISO language lists now. And if you look at the 639-3 list, it's broken out into things like living and extinct languages. So you can do some just browsing if you want. But the main purpose of putting the list in is so that our catalogers can pick it when they're doing their bibliographic description. And that's the picture you see at the bottom. That's our Marva quartz using the list in a pick list. So if you start typing, it narrows down the things you want until you get to the language that you want. We've also put in 2 very small music lists that came from the Performed Music Ontology, PMO, and that's going to be important for people describing music resources using the PMO. And it's also important because we're going to be incorporating PMO into BibFrame in the fall, and so that's upcoming work. So these two lists will help with that. And of course, ongoing updates, we just updated the BibFrame ontology to version 2.6. And actually, every day, the data sets are growing bigger and changing because we get names every day, we get subjects every week, and then quarterly updates usually to most of the other lists on the site. Behind the scenes, we're doing some stuff with language scripts. In the name authority file, you don't have script and language tags, but we're going through and adding them programmatically. So we will look at a record and sniff the Unicode set and decide that this is a Cyrillic and this is a Hebrew language tag, and we'll put in the language as appropriate. This is important for our catalogers who are doing more work in vernacular scripts to be able to identify this stuff, and it will be pushed into MARC in the subfield 7 in bib records. And so there's a lot of work going on trying to fill in this gap where we've put in things in other languages but haven't identified the script. It's still not finished. It's ongoing work. So if you see problems, let us know and we will do what we can to fix it. Also behind the scenes in the spring, we really had a lot of activity that was causing downtime and, well, I mean, like timeouts, not downtime of the site itself. And so some searches were failing. And so we made a concerted effort to look at our database and clean out stuff that had been sort of experimental or never used. And so we cleaned up the database as much as we could. And then we also changed our formatting so that when you look at a record, it does not look up all the labels that came from MARC, the strings that came from MARC at that time. It does that up front. So as we load a record, we do search everything that's related to this thing and bring back and store the URIs. So our stored record is much more triples, like the resource, the relationship, and then the URI. And that way, at display time, all we have to do is resolve the object URI. And so for Bill Clinton, all of these things are very compact, and this is how we store it. And then when we display it, we go out and we expand it into the text and other related items for this. And so this has made our display much more efficient. And most of these labels are cached, so there isn't really that much searching at all. A lot of our work is done up front as we load the records. All right, so some of the service changes. Our suggest to service is the type ahead, so that as you type, if you use this URL, as you're typing, it resolves further and further down to the thing you're looking for. And you can get it back as JSON or XML or whatever you want. And the documentation for that is in the Swagger documents that Chi was talking about. But I've added 2 new parameters that still need to be put into that documentation. One is usage equals true. If you put that in, it takes a little bit longer because it's going to say for a particular name, how many things did that person contribute to, or how many resources was he or she a subject of. So you can turn that on and off if you want. And then for real speed, if you say raw list equals true, you'll just get back the index terms. So if you're really just wanting to know what we have in a particular vocabulary, raw list equals true is your friend. And then we've added more and more fields to the payload of this record. So when you get a response, it pulls out a whole bunch of stuff, and we put it all under more so that it wouldn't break the top level for backward compatibility. And the reason we do this suggest service is so that in Marva and other editors, you can decide how what we have and how you're going to catalog something. So this is a subject builder screenshot, and the person has typed in grave, and it searches first for simple single term subjects, and then it searches the LC-NAF for names, and then it goes back and searches more complex subjects with multiple terms. And the catalogers have said that this is the most efficient way they want to search. So when you start typing, it does these 3 searches and maybe more in some cases, and pulls back as much information as I was saying before to build the panel you see on the right. So it only goes for each search, it goes to ID one time for that search. It doesn't have to keep going back as you float over, but as you float over, it will reveal the things that it found in the first search. So we found that to be very efficient. And then for regular searching, we really have not put a lot of effort into people searching the site, but we did add facets a long time ago, and we're primarily trying to get the data out as opposed to having people browse what we have. So, but we did add alpha sorting for resources under or result sets under 200, because if you return 10,000 and had to sort through those, it would be way too resource intensive. So once you narrow your search down, it will let you sort them by alphabetic. And we've also seen people doing screen scraping of the HTML on the search results. So we made sure that you can now get back the results as XML or JavaScript or JSON using either content negotiation or just right in the browser, say format equals Atom XML, Atom JSON, etc. And you can try these searches out too. And then the documentation is on the left panel at id.loc.gov, the suggest service and general searching. And that's it.
Thank you so much for those wonderful updates. It looks like right now we have one question in the chat, and if others have questions, please do feel free to put them in the chat or Slack. We have a question to ask whether IDLOC will consider putting up Sparkle endpoints in the future.
Well, I don't think so. We haven't thought about that for a while. It's an interesting idea, but I guess we've been mostly concerned about getting, for the past year, getting into FOLIO, and so we've not thought about anything except for supporting that push. Sparkle endpoint is really for people who know what they're doing, and if you don't know what you're doing, you can easily mess up and spend a lot of time and be frustrated. So I think we would want to do a very targeted way of launching something like that. And so it would take a lot of thought.
That's fair. We had two comment and a question. So it looks like the RDF XML serialization of ISO 6393 only includes the top level scheme members. Will an RDF XML version be made available that include all the languages?
Yeah, I think so. We have the ability to export a vocabulary, and I think the same question has come up about RBMS, but it requires us to program the export, and so that's something that's on our list to do. Currently, it's just when you go to the scheme page, it is just that top level set to drive the presentation. So that, yeah, it would be different, but on the list.
Right, and then one kind of more of a common question. I wonder why MARC authorities that have URIs in them already are not hot linked at IDLFC. For example, the occupation from Wikidata, the authority record has the subfield 1 with the Wikidata URI, but in IDLFC, all you see is Wikidata evolutionary biologist.
I'm not sure. I'd have to look at that. It might be a bug.
Good catch then. And we still have a few more minutes for questions if anyone had something to ask. Are there plans to publish vocabularies in MARC documentation, e.g. Leader 6, as linked data? You're muted now.
I think that's probably more a question for Jody. Leader 6.
Oh, and it looks like UW Libraries has published them. So
Okay.
there's some options. Thank you both so much for presenting. I know with the migration, you are both very busy. So we really appreciate you taking time to update us on what's coming from the
Absolutely.
linkage service.
Thank you.
Thank you.
All right, folks, we have a little bit of time left. Our next session is going to be our OCLC virtual booth. That's in another Zoom room. So if you're hoping to attend, please check on SCED and you can get the Zoom link there. All right, folks. Thanks everyone for joining us this morning. Our next session is going to be the OCLC virtual booth, and that'll be happening in about 15 minutes. So you have time to grab a snack, get some coffee, and get started for the rest of the day. Thank you again for joining us.